Hello students, welcome to class 11 physics. In this video we are going to solve the textbook exercise numericals, that is, first we will be solving the fifth numerical, that is 5.5. A constant retarding force of 50 Newton is applied to a body of mass 20 kg. So here we are having force of 50 Newton, mass that is 20 kg, moving initially with a speed of 15 meter per second, that is V0 equals to 15 meter per second. How long does the body take to stop? We need to find t. Here we are going to find the time taken by the object that is in motion after which it stops. So we can write final velocity is 0. So here you can see we are having force, mass, V0, V and T we need to find. Now see, from this data we can use the equation, that is V equals to V0 plus AT. We can use this kinematic equation. V equals to V0 plus AT to find the time. Here we are having value of V, V0, T we need to find, but we need to find the acceleration. So from the force and mass we can find the acceleration value. So here you can see, by Newton's second law of motion, F is equals to ma, so A is equals to F by m. Value of force, that is minus 50, because here it is the retarding force, so we can write it as minus 50 upon mass, that is 20, so its value is minus 2.5 meter per second square. Now using the kinematic equation, V equals to V0 plus AT, substitute the values of V, V0 and A to get the value of T. So what we get over here is 0 equals to 15 plus minus 2.5 T. So taking this on the other side, that is 2.5 T equals to 15. So T equals to 15 upon 2.5. So its value is 6 seconds. So it takes 6 seconds to stop the moving body. So students, you may note down this numerical. Now numerical number 6. A constant force acting on a body of mass 3 kg changes its speed from 2 meter per second to 3.5 meter per second in 25 seconds. So here we are having data, mass that is 3 kg. It changes speed from 2 to 3. That is, initially its speed is 2 meter per second. Final speed, that is 3.5 meter per second. Time, that is 25 seconds. The direction of the motion of the body remains unchanged. What is the magnitude and direction of force? Here we need to find force. So we can use the equation F equals to ma. But here we do not know A. So we will be using these three data to get the value of A. So as you can see over here, acceleration equals to V minus V0 by T, because we know the acceleration formula, that is change in velocity upon time. Change in velocity, that is final velocity minus initial velocity upon time. So put the values of V, V0 and T in the equation, that is 3.5 minus 2 upon 25, which is equals to 1.5 upon 25. Solving this, we get 0.06 meter per second square. So we get the acceleration value. Now we need to find force. So what is to be done? Use the equation of force, that is F equals to ma. Now substitute the values of mass and acceleration, that is 3 into 0.06, which is equals to 0.18 Newton. This force is in direction of motion. So students, you may note down this numerical. Now let us solve 7th numerical. A body of mass 5 kg is acted upon by two perpendicular forces, 8 Newton and 6 Newton. Give the magnitude and direction of the acceleration of the body. So, we are given mass 5 kg. Here we are given two forces, F1 8 Newton, F2 6 Newton. And we need to find the magnitude and direction of acceleration. So clearly we are having force data and we are having mass. We need to find acceleration. So what we need to use is F equals to ma. But here we are having two kinds of forces, two types of forces. So first we will be finding the total force. And then we will be using the equation F equals to ma to get the value of A. So here, as you can see in the figure, these two forces are perpendicular. So from this we can take magnitude of the total force, that is under root of F1 square plus F2 square, because here you can see that one of the forces along x-axis, one of the forces along y-axis. So you can consider its component. Force component along x-axis, force component along y-axis. So F1 square plus F2 square. Put the value of F1 and F2, we get under root 8 square plus 6 square. That is under root 64 plus 36, which is equals to under root 100. So F is equals to 10 Newton. Here F equals to 10 Newton. Now using the equation F equals to ma, that is 10 equals to ma. Acceleration is equals to F upon m, that is 10 upon 5, which is 2. So acceleration is 2 meter per second square. Now let us find the direction. So from this figure we can write 10 alpha equals to F2 upon F1, because we can see from this triangle, taking this alpha, 10 alpha is opposite upon adjacent. Opposite is that of equal to F2 and this adjacent is F1. So we can write 10 alpha equals to F2 upon F1. F2 that is 6 Newton, F1 is 8 Newton. So 6 by 8 that we get it as 0.750. So 10 alpha equals to 0.750. When you see this in natural tangent table, you will be getting the value as 36 degree 53 minutes. So resultant force make angle of 36 degree 53 minute with 8 Newton force resultant force, and acceleration are in the same direction, that is the resultant force and the acceleration both are in the same direction. So students, you may copy down this numerical. Now let us solve numerical number 8. The driver of a three-wheeler moving with a speed of 36 km per hour sees a child standing in the middle of the road and brings his vehicle to rest in 4 seconds, just in time to save the child. So here we can say that the initial speed of the driver vehicle, that is 36 km per hour. When we convert that into meter per second, we can write 36 into 1000 upon 3600, that is 10 meter per second. So initial speed or initial velocity, that is 10 meter per second. Final velocity is 0 because he tends to stop the vehicle. So vehicle comes to rest, so its final velocity is 0. Time taken, that is 4 seconds. What is the average retarding force on the vehicle? So we need to find F. The mass of the three-wheeler is 400 kg and the mass of the driver is 65 kg. So we are given M1, that is 400. Let us consider M2 as the mass of the driver, that is 65 kg. So we are given this data, M1 is given, M2 is given, V0, V and T, that is given. So we need to find F, so we can use the equation F equals to ma. For mass, you can consider the total mass, that is mass of the system consisting of the vehicle as well as the driver. And for the acceleration, we can use this data V0, V and T to get the F value. So first of all, let us get the value of acceleration, that is change in velocity upon time, that is V minus V0 by T. Put the values of V, V0 and T, we get 0 minus 10 upon 4, that is minus 2.5 meter per second square. As well as let us see the total mass of the system consisting of vehicle and driver, that is M equals to 400 plus 65, that is 465 kg. Now to find the force, we can use the equation F equals to ma. Put the value of M and A, that is 465 into minus 2.5. Value is minus 1162.5 Newton. Its magnitude is 1162.5 Newton because here minus sign shows the direction. That is, the direction of force is opposite to that of the acceleration. So, student, you may note down this numerical.